We'll start today by looking at arithmetic sequences and series. So we have an example of an arithmetic sequence above. And you see -8, -5, -2, 1, 4, 7, and 10. And I think most of us, without very much thought, could come up with the next number in the sequence if we had to. It looks like the rule is to add 3 every time. But if we were asked for what's the 23rd number in the sequence, well, that would take a little bit. We could make a list of 23 numbers if we want to. It would take a little time. But what if we needed the 10,000th number? Nobody wants to make that list. So the question is, do we have an easier, more convenient way of doing that? So 3, 6, 9, 12, 15 would be an example of an arithmetic sequence. And what makes it arithmetic is that the difference between consecutive terms is constant. So we have a constant difference between terms. It's called a common difference, and we use the letter D to denote it. And the way that we find that is we subtract one term minus the term just before it. So in this particular example, if I took term 2 minus term 1, 6 minus 3 would be 3. If I took term 3 minus term 2, 9 minus 6 would be 3. Term 4 minus term 3, 9 minus 12 is 3. So each time I subtract, I get the same difference. That tells me that it's an arithmetic sequence. So let's look at a couple of examples. We can use that fact to determine if a sequence is arithmetic or not. And so 0, 7, 14, 21, 28 are our first example. And so in order to do that, we need to find the difference of consecutive terms. So we start by taking the second term minus the first, 7 minus 0, and we get 7. If we take the third term minus the second, 14 minus 7 is 7. And so forth. If we take each successive term minus the one that precedes it, we get 7. 21 minus 14, 28 minus 21. Every difference is 7. So because the difference is the same, that's a common difference, then we say that sequence is arithmetic. What about an example B? 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. So the differences are not the same. So this is an example of a sequence, but it's not an arithmetic sequence. Here's a couple for you to try. 1, 8, 27, 64, 25, and 1, 4, 7, 10, and 13. Let's do the first one together, then you can pause the video. Try the second one on your own. So remember, we're always taking one term minus the one that precedes it. So A2 minus A1, that's 8 minus 1, that's 7. A3 minus A2, 27 minus 8, that's 19. Term 4 minus term 3, 64 minus 27. And that's going to give us 37. Well, it's obvious that these are not a common difference. We don't have the same value when we subtract it each time. So, not arithmetic. So, go ahead and pause the video. You try number 2. And then you can come back and check your work. So let's check your work on the second example. So 4 minus 1 gives us 3. 7 minus 4 gives us 3. 10 minus 7, that's 3. 13 minus 10 is 3. All the differences are the same, so this is an example of an arithmetic sequence. So just as in section 1, we started off by saying to ourselves, okay, so if we have a sequence, can we turn around and write the rule for it? And as long as we can identify the first term and the common difference, then we can write a rule. The nth term of an arithmetic sequence, if the first term a sub 1 and a common difference d is found by using this rule. A sub n equals a sub 1 plus the quantity n minus 1 times d. So as an example, we have a sequence 20, 18, 16, 14, and so we're asked to find a particular value in the sequence. So once that happens, we need to plug in that number in place of n and evaluate. So we're doing two things here. We're writing the rule, and then we're finding a specific value. So in looking for the common difference, we're subtracting one term minus the one preceding it. So 18 minus 20, that's negative 2. Always very careful to make sure that you actually subtract minus the term in front of it. The common difference can be negative or positive, and it's important that you differentiate between the two. So we have a common difference of negative 2. So a sub n equals a sub 1, that's 20, the first value, plus n minus 1, we're going to leave it that way for now, times the common difference, negative 2. Simplifying that, 20 minus 2n plus 2, combining like terms, we get 22 minus 2n for our rule. Now, looking for the ninth term, we're going to substitute 9 in place of n. 22 minus 2 times 9, that's 18. 22 minus 18 is 4. So the ninth term of that sequence would be 4. So your turn to try now. Write a rule for the nth term of the sequence, 3, 5, 7, 9, and then find term number 12. Go ahead and give that a try. Pause the video, check your work. So how did this one work out? So a sub n equals a sub 1 plus quantity n minus 1 times d. So we need to find d, and we're already aware that this is an arithmetic sequence, so we're just going to subtract. a2 minus a1, 5 minus 3 gives us 2, so we know our d value is 2. A sub n now equals a sub 1, which is 3, plus n minus 1 times our d value, which is 2. So now we do the distributive property. 2 times n is 2n. 2 times negative 1, negative 2. And let's simplify here. 3 minus 2 is going to be 1. 2n plus 1. So our rule, the first thing we were asked for, write a rule, a sub n equals 2n plus 1. Now we use that rule to find the 12th term. I was thinking the example, I tried the 9th term. Let's go ahead and fix that real quick. So we substitute 12 in place of n. 2 times 12 is 24 plus 1 is 25. So a sub 12 is 25. Let's see if we can work backwards for our challenge. Write a rule for the nth term of the sequence. We're given a sub 4 and d is negative 3. Well, let's go ahead and write down our general form. A sub n equals a sub 1 plus n minus 1 times d. Well, what do we know? The d is negative 3. Now, we know some value. We know a sub 4. So let's go ahead and say a sub 4 equals a sub 1 plus 4 minus 1 times negative 3. So 10 equals a sub 1 minus 9. So our a sub 1 is 19. Awesome. So a sub n equals a sub 1 plus n minus 1 times our d value. Let's plug in what we know. A sub n equals 19 plus n minus 1 times negative 3. So, similar to other equations that we've solved all throughout algebra, we take what we know, plug that into our form, and then work backwards until we find out what we don't know. And once we can narrow that down to just one thing, we can go ahead and solve. So we talked about sequences. We also talked about series. Sequences are strings of numbers. A series is a sum of those strings of numbers. So the expression formed by adding the terms of an arithmetic sequence is called an arithmetic series. And so if we're adding up the first n terms of a series, we've got a formula for that. We call that S sub n. So the sum of the series of the first n terms, and this is the formula. S sub n equals n times, and then in parentheses, a sub 1 plus a sub n over 2. We're literally taking the average of the first and last terms, multiplying it by the number of terms, and that'll give us the sum of the sequence. And if you look at this mathematically, you'll be able to see why this works. So the sum of the first n terms is the mean of the first and the nth terms times the number of terms. So as an example, There was a visual that goes with this. It's a house of cards where each level is made up of triangles of 3 cards. So the first row has 3 cards, and then the next row has 2 triangles, that's 6, and then the third row has 3 triangles, so that's 9, and so forth. So using this and this example, we're able to determine the total number of cards in the entire house of cards if it's made up of 20 rows. And as you can follow through in the example, it turns out to be 630. So let's look at a couple of examples. We'll do one together, and then you can try a couple on your own. Pause the video and check your work. So S sub n equals n times a sub 1 plus a sub n over 2. All right? So we have 2 and 17. So S sub n equals 1, 2, 3, 4, 5, 6 terms times 2 plus 17 over 2. So 2 and 17 is 19. 6 times 19 halves, right? So that's 9.5. And you go to your calculator. And you find out that that is 57. Go ahead and pause the video. Try the next 3 on your own and check your work. Okay, let's see what you got. In number 7, we started with -4, went to 16, and there were 6 terms altogether. So the sum of the sequence, the first 6 terms, 6 times the average of the first term and the last term, -4 plus 16 over 2. So that's 12 over 2, which is 6. 6 times 6, 36. Let's check out number 6 and number 8. Number 8 also a 6-term sequence. So 6 times average of the first and last. 5 plus 10 is 15 divided by 2. That's 7.5. So 6 times 7.5 gives us 45. Number 8, careful here, they only gave us the first 5 terms. So each of the previous contained 6. So you have to keep on your toes a bit. 5 times average of the first and the last, -9 and 19, that's +10, divided by 2. 5 times 5 is going to give us 25. So sequences and series, take a moment to summarize your thinking, to kind of cement it inside of your mind. Flip the page, write down 3 things that you learned today, 2 things that you want to know more about, and 1 thing that you still have a question about, and there's some space for sketching, making any type of graphic organizer or connections to other classes or previous topics in this class or other math classes.